Okay, so here we're going to do a horizontal asymptote. Okay, horizontal asymptote. First example, something like this. There's three rules you need to know. And if the degree of the bottom is bigger than the degree of the top. Okay, so the degree. The degree of the bottom is bigger than the degree of the top. So the degree is the highest variable exponent. On the bottom is 1, and on the top is 0. So the degree of the bottom is bigger than the top. The horizontal asymptote would be y equals 0. Okay, and the reason for that is as x gets bigger and bigger and bigger, the bottom gets much larger than the top, and the ratio gets very, very small. So it gets closer and closer to 0. It's kind of sort of a calculus idea of a limit. But for now, it's best probably just to memorize if the degree of the bottom is bigger than that of the top, the answer is y equals 0 for your horizontal asymptote. It's always y equals 0, no matter what these other numbers are. Now, if you flip that, write nearly the same thing. Let's say you've got this graph. So the degree at the top is bigger than the bottom. Because I'm using these loose phrases. You could say numerator and denominator. Here, the degree at the top or the numerator is 2, the degree at the bottom is 1. Here, there is no horizontal asymptote. You actually, in this case, would have something called slant asymptote if the degree is exactly one more on top than on bottom. Okay, but in general, you're not going to have a horizontal asymptote if the degree on top is bigger than the degree on the bottom. All right, so let's now look at the third scenario, which you might imagine what they're the same. Okay, so something like y is equal to 5x squared minus 1 over 6x squared plus 3 to kind of keep it simple. So here the degrees are equal. So top degree equals bottom degree. Okay, if that's the case, then you're going to take the ratio of leading coefficients. Ratio of leading coefficients. Okay, if you remember, the leading coefficients, the number in front of the highest power. So here it would be 5 and 6. So your horizontal asymptote in that case would be y equals 5/6. Comes from these two numbers right here. Make sure you are in fact getting the true leading coefficients. Okay, because sometimes these are not in order. All right, so we're going to take all that. We're going to graph one now. Try to find a graph that looks not too dirty looking here. Okay, we have a graph. We want to graph. We'll do one with the like we just learned here. Let's say we have something like x over 2x minus 6. Okay, and we're going to graph this by looking at the asymptotes. So we're going to let Desmos help us some here, but we're going to at least put the asymptotes in. So here we have a vertical asymptote, which is a previous video. But the vertical asymptote is when the bottom is set equal to 0, as long as you don't have, you make sure it's simplified first. You get all the canceled factors out of there. And here it doesn't simplify. So I've got 2x minus 6 equals 0. I add 6 to both sides and divide by 2. So my vertical asymptote is x equals 3. Now in this case, we do have a horizontal asymptote because they're equal. The degrees that we just talked about. So it's going to be y equals 1/2 right here. Okay. So what I'm going to do is put those in on this graph here. So x equals 3, 1, 2, 3. I'm going to put a vertical line, and I'm going to dash that line. The reason I'm dashing that line is because it's not actually part of the graph. It's just a sketching aid. So x equals 3 is a vertical line, vertical asymptote. Horizontal line, y equals 1/2. So I'm going to go 1/2 above, like this. Okay? So notice that this is 0, this is 1, so we're at 1/2. Let's go to Desmos and go from there. So let's go to Desmos. Here's the Desmos screen. I'm going to graph what I had there. And it is y equals x divided by 2x minus 6. You can see that line x equals 3 and y equals 1/2. You can see what asymptotes are. The lines that the graph is actually the purple part, but you can see how it forms in those lines. It approaches the black line, the red line more and more closely. So back on my picture, the way it looked was it came through here like this and like this. Okay, so it kind of curved away from those. And it's actually not a very good picture. It needs to more and more closely approach that line. It doesn't need to come back off of it. Okay, it gets closer and closer to that line as you go here. So that would be a good graph. And of course, you could graph it by hand by plotting some points. But right now we're just focusing on what those asymptotes are. One more quick example.